Okay, so we're starting geometry and trigonometry today. So the first bit we're talking about we're doing geometry. So we're going to look at the rules for parallel lines. So parallel lines are, when we have them, they're running in the same direction, and they'll indicate them with those arrows. So often it's good to highlight when you see them in your question, to make, highlight them, make note that you've got some parallel lines there. Now what they often say is then if you have a line that's intersecting, so you can see this line is cutting through the parallel lines. So when you say that, we know for a fact that this angle here, so the one in between there, is equal to the alternate there. So it's like with the zigzag. So even if I had it like this and I cut a line through, so I'm saying this angle is the same as that angle there. Okay, alternate on the zigzag. So that's one thing you need to know. Now also, if you have parallel lines, if you have co-interior, so you can see they're inside that section. So if you've got your parallel lines, we're saying co-interior, they're in here, they will add up to 180. Okay, so it's something you need to remember. This fact that a straight line adds to 180, you'll use that all the time, and that can often save a lot. And then you've got to remember that 90 degrees and right angle is 90 degrees. Okay, some other ones. Just remember, if you can draw a circle around, then all of them must add up to 360. Okay. There's also, they've got the parallel lines again here. So we have the parallel lines, and then we have this intersecting line. So the angle in the same spot in the pattern. So say, for example, if I had it like that and I go down like that. So what I'm saying is the same spot in the pattern, they're equal, as long as these are parallel. All right, a few other things. Vertically, if you've got two lines, remember opposites are equal, crossing like that. And then also you just need to remember that obtuse angles are greater than 180 and acute are less than 90, reflex 360. You never have to write a definition. You don't need to that. It's just like mini facts you need to know to help you solve a problem, okay? So you've learnt them all when you were young. You probably had to define them. That was for us to try and learn them. And now we're going to use them to help us solve problems and things like that. Okay. So let's have a look here. So if you have a look at these two, and what we're trying to find here, we've got this angle and this angle. They are actually alternate angles because I have two parallel lines. So I've got two parallel lines here and a line intersecting. So I've got alternate angles. Now we know that alternate angles are equal to each other. So that means I can write 2x minus 50 must equal x plus 10. When you have an equation like that, so an equation means I've got the equal sign there and I've just got an x, you can always just use solve. Some of you may be able to algebraically solve it, that's okay, you can do that, but you don't need to, just use your solve if you're not confident. So this one would end up being x equals 60 degrees, okay? Now with this one down here, we've got two ones we don't know, so we've probably got to work out one first. And what I'm going to do is I'm going to work out the x1 first. So I can see here these two, and that's alternate angles again. Okay, so it's alternate, they're alternate angles. So that means I can let them equal each other. So I've got x plus 100 must equal 2x plus 80. So we end up with x equaling 20. So once again, you can use solve. Don't worry, I'm just doing that in my head, but yep, x equals 20. Okay, so now I know that, what I'm going to do is I'm going to say that these two angles are co-interior and they must add up to 180. So we now know x is 20, so we now know this is 120 degrees. So I can write out a little statement. I can say 120 plus y plus 60 equals 180. And you can solve if you like, but what does that make? Y would have to be, it's actually 0. So what Matt just asked then, he said he saw that as a straight line, so he knew those two had to add up to 180. And that's the case in geometry and trig. There can be multiple ways of working it out. You might see it differently. You should get the same answer. The next thing we're going to look at is some triangles. So we just got to remember a few rules. Now, we know we've got to remember that all the angles inside a triangle add up to 180, yeah? So most of you can all remember that. Now here they're saying, so they're saying that C and D add up to 180. So you could probably justify that anyway, because you could see that's a straight line, isn't it? And we know a straight line is 180. So there's sometimes you could see it like that. They're saying the exterior angle will add. Okay, so we've got different types of triangles. So they might talk about a triangle being equilateral. So if you have an equilateral triangle, they will indicate that all the sides are the same. That means they're all the same. So if that had a side length of x, then all of them would. And if it's an equilateral, they always have their angles of 60 because 3 of them will add up to 180. Okay, this one, you don't need to, the next one, this bisector. What they're saying here, they say the bisector of each angle. What a bisector is, I'll draw it out for you. So if you have a triangle, what a bisector is when you go from the tip, one tip, and you go straight down and see you're breaking this exactly in half, yeah? So that's the bisector. So this line here is called a bisector. And so obviously I could put another bisector. I could go from that tip and go, you know, and cut in half there. So that would be, that would be another bisector. That's what they're talking about here. And they say when you, the triangles meet on the opposite side, my diagram's a bit off, but we're saying that that's a right angle if you have a bisector, okay? So I've never really, you don't get too much of that language. I don't think I heard bisector much in a further exam, so don't stress too much. Okay, the next one down there, an isosceles triangle. That's when we have two sides are the same. And just maybe take note, if that the bottom, or those two angles opposite the sides that are the same, they are equal. So if there were x, they'd both be x. Now, when they talk about this exterior angles equal 360, what they're talking about is if you extended the line on the triangle like that, they're talking about this to here plus this to here plus that to there. That will equal 360. But you don't really need to worry. I reckon you'll see more, the thing you'll see the most is like the straight line, and you'll be able to work it out, most of the questions. So let's go have a look here at a question. So we know that the inner angles of a triangle have to add up to 180. So I know that 22 plus 20 plus x needs to equal 180. So x equals 138 degrees. So if you have to put solve, you can put solve. So you now know that x is 138 degrees. Maybe now we can see, here we've got a straight line, haven't we? Yeah. So we can say it's 80 degrees. So we know that x plus y equals 180, but we knew x was 138. So we're going to say y equals 42 degrees. There is a rule to say this exterior is equal to the opposite too. But who cares? Like, if you can see the straight line, just work it out that way. It doesn't make a difference. All right, here not that we need it too much. Well, we can see that this would be an isosceles. So say you might have had something else, you know that those two sides are equal. But really, we know that all the angles in a triangle need to add up to 180. So you could have had, you could have worked that out easier anyway. So x equals 40 degrees, but as I said, you can always use solve. Just write out what you know and do solve. No problem. Okay, so here, this is an exam question. So what I want you to start thinking now, because we're getting close to doing exams, is that in this chapter, in TRIG, you'd have 9 multiple choice questions. So we're thinking of that 5. That's a halfway mark. They're generally not as much straightforward. If you're on question 1 and you think, oh my God, it's so straightforward, it probably is, yeah? But question 5, maybe not so much. So let's have a look at this. So it says the length of the line first up here it says triangle ABC and D lies on the point AC, so that straight line, a line there. So the length of the line BC is equal to BD. So really all they told me there is they're pretty much saying, and they've indicated it, haven't they? They've shown us anyway, that that's an isosceles triangle. So what we might do, and what you should do, is when you read stuff, this is what will help you in this chapter. Put things that, as soon as you know, oh, that's an isosceles, all I do, sometimes I just go, okay, well, I know those two angles are equal. So I might give it a letter, or I just put a shape there to help me, and I go, all right, I know that. And they're going to ask me which one of the following is true. Okay, so let's go through it. When it says angle BAD, so what I'm going to do, I'm going to write that as well. We could write that as angle BAD like that. What they're referring to, it's the one in the middle. So I'm going to give it a shape of a triangle. So where they're looking at is they're going B, they start at B, they're going down to A and across to D. So they're talking about this angle in here. Okay, and I just gave it a triangle just so you know. Okay, and then they said BAD is equal to, and I'll do the other one. So when they say AD, so when they say angle ADB, they're actually talking about that angle at D. So they're talking about, I'll just draw another circle there. They're talking, oh, I'll make it a square. They're talking about this guy here. There you go. Now they're saying, the first statement was that blue triangle, does that blue triangle, does it equal that square angle? Just even looking at it, does it? No, so we know that's not correct. Then the next one, it says angle ADB. So that was our pink square, is equal to BDC, which is our circle. Okay, so are those two equal? No, they're not, are they? No, they don't. Look at it there. Do they look the same? No, they're not equal. Okay, and then the next one, it says angle ACB. So what ACB is actually this circle there. Is that equal to ADB, which we called the square? Well, that one is, isn't it? Because does those two angles add up to 180? Do they? Yeah, they do. Even though they were talking about this one here, it's the same as that other green one. And because I've drawn it up like that, you can see it, and it makes it easier. So this answer is the correct one. That is true. When you go on with your exams, what you should do is just make note that you've got to check, like even put a little arrow or line down there. When you go back and you've got time to check that those two are wrong. Yeah? Because sometimes you do it and you go, oh, I get that one being right too. Then you'll know you've made a mistake somewhere, so you can go have a better look at it. But if you check the same things that you did, you will generally make the same mistake. You know, it's just our human nature. So we want to try and always check a way that we haven't done. That's a way to do it in this instant. All right.